Okay, I'll be making lecture summaries where I teach the exact same stuff they do in a 50-minute lecture, but way better and in a fraction of the time. We're just covering the fundamentals here. The natural numbers is a set of whole positive numbers starting with 1, the integers are whole numbers including 0 and negative whole numbers, and the real numbers are any point on the number line. Now this is the notation we use to show the intervals between a and b, but the square brackets include the endpoints, but the round brackets don't. Set operations. Let's say we have two sets, a and b, that are subsets of omega. A union b means it can be in A or in B. A intersection b means it has to be in A and in B. And if A and B have no overlap, then A intersect B is the empty set. Complement of A is everything outside of A, and A/B is called the set difference. We take out the overlap with B. Now if we have a whole bunch of subsets of omega and we want to show the union or intersection of all of them, we can use this notation. This is just the shorthand version of this, in the same way how sigma is the shorthand version for addition. Now if for this collection of sets the intersection between each one of them is the empty set, we say it's pairwise disjoint. There's no overlap between any of the pairs of these sets. Now for the Cartesian products. Doing it between two sets will give the set of all possible pairs where the first element is from x1 and the second element is from x2. So doing the Cartesian product between these two will give this. Now if we did it with a set of hats, set of shirts, and set of shoes, we'd get the set of all possible outfits.
Legit boss ass nigga.
Now if you multiply k sets together where they are all the same, you could write it as x to the k. If we had this set, x to the 3 would be all the 3-digit combinations of 0 and 1. Now these are real numbers, so this vector of 3 elements is a member of the reals cubed, so 3D space. So for a vector of I real elements is a member of r to the I. It has I dimensions. The absolute value of a set is the size of the set. So if A has 3 elements, the absolute value of A is 3. Now if we have an infinite set A, we say it's countable if we can map it to the natural numbers. So of course the set of natural numbers is countable, but so is the set of positive even numbers, because it's just the natural numbers times 2. Any subset of a countable set is either finite or countable. And like I said before, sigma notation is shorthand for addition, but we can use capital Pi for multiplication. And of course we can also sum to infinity, which is just shorthand for this. And this only works if this limit exists. And here's some identities you should know for series. Okay, now for actual probability notation. Capital omega is the sample space. This is the set of all possible outcomes. Little omega is the outcome of a sample space, and A, which is a subset of capital omega, is an event.